All right, we're starting up part two here, and kind of coming to the conclusion that we have some leaky capacitors at the very least. Our voltages are way off, especially like our negative bias voltages and things like that, the grid voltages on things, um, all over the place. And I just think we have some really badly leaky capacitors. I'm a little bit disappointed because the description of this when I purchased it was that um, it was working perfectly and picks up lots of stations on all the bands and all that, and obviously that was not true. But again, I got a really good price on it, so it's as I would have expected. That would have just been icing on the cake if it worked. So what we're going to have to do here is I'm just going to go ahead and recap this whole thing. And when I recap it, I am going to, each part, as I take each component out to replace and test, I'll make sure that it anatomically matches up with the schematic so that if there's any mistakes in here, we'll catch it. But really, with the exception of these four components here, everything in here looks totally original. So all the solder joints look like they've not been changed at all. Whoever did this used the coil method when they added these components on. You can kind of see how they did it. So I can take them out. I'm going to recap this. I'm not going to use the coil method. I'm actually going to clean each of the solder terminals off. I have a way that I do it. I'm very careful, and I just think it looks more original and more professional to do it that way. If I'm just replacing one component like I were doing this, I would definitely use the coil method. Coil the wire around, like spiral the wire around the cutoff lead, and no harm, no foul, it works. But redoing an extensive redo like this, I'm going to clean off the terminals very, very carefully and replace each one of them. And what I'll do is I'll go through with you how I clean off one of these terminals the safe way, and try to do this in a way that it'll look original just about when it's done. So I'll do one of those with you, and then I'll come back, take care of all this, and when I return, then we'll have it all done. And while we're in there, we're going to measure all the resistors. But again, there's certain resistors, even if they're off, we're not going to touch them if they have anything to do with frequency, like with an oscillator or something. The only ones I'll replace are ones that deal with biasing and things like that if they're off. And then we'll take it step by step from there. So here we go, and with part two, and hopefully I will try to keep this one a little bit shorter than the last one. It went up over an hour, which I really didn't expect that, on a multi-part, but I guess I got a little bit long-winded with y'all. So, okay, here we go. All right, a little update here. I haven't even started recapping this thing yet, but almost every resistor in here is out, some of them by a country mile, and I'm not talking 10 and 20%, I'm talking a lot. So the majority of the resistors are going to need changed. No wonder the power is like all over the place in here and all the voltages are wrong. These resistors are horrifically off. And I've removed all the tubes from the sockets. A lot of these pins are open pins, so I'm not reading across anything. They're just reading sky high, which is what these carbon comp resistors do. There's 2 or 3 of them that were pretty close to being on, but when I say 2 or 3, that's really what I mean, like 2 or 3. So looks like this is not going to just be a recapping, but it's going to be re-resistoring, and that just makes me feel even more that this thing has been in an environment that wasn't good for it or something. I don't know. I don't see any rust on the chassis whatsoever, but still you have to wonder if there was humidity or something got into these components, because they're bad. So I just got this reworked over here. I put in a new safety cap capacitor. I had to change this terminal strip because it was cracked. so it needed replaced. I think somebody had replaced this cord at one time. So that's all done, and we're just going to go little by little, each little section, and just replace everything. But the only thing I'm going to leave in here, like I said, is mica caps and anything on this side, over here that has to do with the the frequencies and things. Try to avoid that whenever possible. So, all right, I will keep you posted here as things progress. Okay, as I said, a lot of the resistors in here were bad, and obviously the capacitors need replaced. So this is going to need pretty much a full restoration. Now, how do we do this? I know we talked about, spiraling the wires, clipping the leads off, and then spiraling the wire of the new component around the old one. But I don't really like to do that. It really gets messy when you do a whole bunch of components. So the other option is to clean the terminals of the tube sockets off totally. It's a very tedious and time-consuming process. There's no easy, quick way to do it. And a lot of people say that you'll break things doing that because you can't unwind everything. But I'm going to show you how I do it. I've been doing this for years, and I've almost never had any problems with it. If we zoom in, I've already done one socket. So if you look down here, this section, this is the output tube. And you can see I've got it pretty much cleaned off. All right. Now, to do this, you need several things, okay? First thing, it really helps to have a desoldering tool, a vacuum one. This one's an all-in-one. It's expensive, but it's worth it. You get what you pay for. But there's also two-piece ones that have a base unit that has the pump and the power supply and everything, and then the handheld unit, the grip is much smaller and lighter, but it has a hose coming out. It works really well too. But you really kind of want one of those. A good desoldering pump, okay? You use this to get, if there's a giant blob of solder, like if you look at this area, there's a lot of solder on there, okay? So I would heat that up with a soldering iron. I would pull off the majority of it. Then I would use the vacuum pump to get the rest of it. Then you're also going to need a little bottle of RA flux. And I'll tell you why here in a second. And last but not least, for the final cleaning, we use a little piece of solder braid. Okay. Now, how do we do this? So, let me demonstrate. I'll do one of these terminals over here. This resistor goes from, there we go. Now, of course, I'm going to be working around the camera, so it's going to be a little more complicated. And so that I don't get this smoke into the camera lens and mess up my camera, I do have my, back up here, I do have my solder smoke inhaler set up. These are great. They have like a carbon filter in them, and when you're working with lead solder and when you're working with flux, it makes a lot of smoke. People with allergies especially can have sinus problems with this and stuff, so investing in one of these is great. If you can't get one, you can buy them through MCM Electronics and many other places, eBay and other places. But this one's really nice. They sell replacement filters, and I think the thing only costs like 30 bucks or something. So if you do a lot of soldering, it's good. If you don't, get yourself a small fan, a little tabletop fan, and just let it blow away from you so that the smoke goes away from you when you're working on it. You won't regret it. So anyhow, let's zoom in. This resistor going from here to here. I'm going to do this terminal. I'll do the whole process with you. It's going to get a little loud because I'm going to have to turn on the fan, but you can watch how I do it, okay? And I'll try to do this around the camera. So first of all, you don't want to bend anything too much because you can break these little tabs off. And you notice how stiff some of these wires are. And you don't want to dwell on there too long because some of these carbon resistors do not like being heated up. So, you kind of have to go on and off a little bit. So this one's not too big of a blob of solder, so I'm not going to use the vacuum pump or this desoldering pump. I'm just going to use my desoldering gun, okay, and start with that process. Now if there was a big blob of solder, I would take my iron and I would heat it up, and I would take the pump and I'd pump the majority off and then finish it with this. But we're going to get in here and do this, and I'll see. I'm going left-handed and I'm a right-handed person, but we'll see what we can do here. So you heat it up, kind of move it around a little bit, turn on our fan. Okay, so that gets it down, as you can see, that gets it pretty good. Okay, so next process is we take our RA flux and we put a little drop there, and then we take our desoldering wick, which is right here, and it's getting kind of, I just cut a piece off because I don't like holding the roll, so I might burn my fingers because it's getting short. But so you take this and you put a little bit, really important to put some on the wick itself. It helps it to draw up the solder. Now watch how clean this is going to get it. Okay, it's going to smoke, but when we're done, wow, this is hard around the camera. So we get this in here, and you can see how this thing's turning all silver, the wick. See, as it picks up all the excess solder. See it? There we go. Come on, focus. There we go. And you can see how clean that is now. Okay? Now, to remove a terminal, the way I do, or to remove a wire, a component, I don't always use needle nose. So we have a pair of needle nose that we use, but I also use these really fine tipped cutters. Okay? And I find that they work better. So what you kind of want to do is, so this lead here comes around and it comes to here, see it? So what you want to do is you want to kind of get under it and kind of use your pliers as a wedge and just kind of pry it away. Now you got it away from there. Now grab your pliers. You can see I'm working around this camera here. You got it opened up. See that? Now, if it's loose, that's all there is to it. You can move it out. Okay? So, actually I moved this one here, see? Sorry. Like I said, I'm trying to work through this camera. So, we got this one out of the way. So now let's take this one. And see how tightly wrapped that one is? Sometimes you can unwind them, sometimes you can't. If you can't, get on the curve where it's curved, but don't cut the tab, and you can just snip it. Okay, like that. And that just leaves this little end. Okay. And again, I'm doing all this through the camera, so it's a little bit tougher. But there it is, now it's loose. And as you can see, if you take that out, I'm going to put it back in so I don't lose my place. But you can see how clean that is now. And when you put your new component in, and you notice I barely disturbed the actual terminal for the tube socket. That's the whole goal here. We want to not make any more disturbance of these terminals as we have to, because these are so thin, if you bend them back and forth several times, they'll break. So you have to be very careful. And like I said, the RA flux makes a big difference. It helps the solder wick to absorb all the excess solder. And going in stages, taking the biggest amount of solder and working your way down. And if you do that, like I said, I like to clean off a whole socket. So you look at this, it's all cleaned off, or at least clean all the components on the socket I want to take off. You know, if there's one I'm not touching, I might leave it. Then what I'll do, I'll get my components one at a time, I'll do each terminal one at a time. As I do one terminal, I'll resolder that terminal. Then I'll move to the next. And when I'm done, I have all my components done on this tube. It's a lot easier that way because it can really get confusing if you jump around. The name of the game here is to not lose your place. It's really easy to get too many components off. Never take more than one component at a time out. And if it's one of these ones where there's two components on one terminal you're replacing, do the two, but put them right back on immediately so you don't forget or lose your place. Also, take a lot of pictures. You know, this video's good, you know, this video's for you, but it's also for me because I can go back and look at this video if I get lost and if I get something misplaced, I can check my work. Okay, normally a job's not as extensive as this one because typically you'll do the little capacitors and you don't worry about it. You know, usually the resistors are within their 10 or 20%. This is a 10%. You know, the ones with no silver or gold are going to be 20%. And usually you're within that, even though they're a little bit high usually. These ones are pretty bad. You know, this is not orange, this is brown. So this would be a 6, and that looks like it could be a gray. So that'd be 690 ohms. And when I put my meter on this resistor, and there's no tube in the socket, so I mean it's an open circuit, so I'm just reading the resistor. My 690 ohm is 850 ohms. Okay, so almost 200 ohms high. All right, and this one here is a 470K, and if you measure that, it's reading 780K. So they're way, way, way off. This little 10K resistor down here, okay, I'm checking on the 10K, clip on that, it's 12K. All right, so as I said, I mean, if the 10K was, you know, 11K or something like that, I wouldn't worry about it. But some of these are really dramatically off. And the funny thing is, in these Hallicrafters receivers and some of these old radios, you see these little teeny skinny resistors. They're super skinny. Those are usually super high resistance resistors. For instance, that one, I believe, is, let's see what it says, 15 meg is what they're calling it. I don't know how they're getting that color code to be 15 meg, but when I measure it, it's 16 meg. So it's pretty close. That's not real bad. And that's what I find with these ones. These little ones usually never drift. These normal carbon comps, they drift. And they drift a lot. And I know a lot of people are really into, they say it adds vintage sound to amplifiers and all that. And well, the vintage sound is, you know, probably when that amp was brand new off the shelf, it didn't sound like that. It sounds like that now because these resistors have aged. They've gone up in resistance, which is changing the voltages on your tubes, and they get noisy because there's like carbon in there. Okay, I'm back. We had a tragedy. We have a yard sale going on, and we put a grill out for sale, and lo and behold, it had some bees in it, so I had to go save the day. But I'm back. Where were we now? So anyways, that's how you clear these off. Now what I'm going to do is I'm going to go through and replace each of these components just the way I showed you. And when I'm done, I'll come back. I want to try to keep this video a little bit shorter. I may even end this video here and then come back the next part 3 with you know, how it looks like when it's all done. So that way, that last one got out of hand. I mean, it was like part 1 and it was over an hour. So, and to make matters worse, I tried this video converter to make the file a little smaller to upload, and no matter how I did it, it seemed to go from from 16 to 9 down to 4 to 3, so it's like everything looks scrunched. So I'm going to upload this the traditional way, like I've always done. So hopefully this video will look a bit better than the last. So again, I'm going to call this one part 2, and this was just how to clear the terminals for replacing components, and then we'll come back and look at it with the components replaced.